Alright. You mic again. So let's see how this sounds. Alright. So I know yesterday I told you guys I'm gonna do a lot of cat today. Oh, actually, it peaked a little. I need to lower the one sec. Lower this gain really quick because it was peaking. Right, I was gonna say what was saying? Yes, I was going to spend the day fixing the cat on this thing. Oh, might sound good. Thank you. But then as I look into the cat of this thing, I realized there's a bunch of other stuff that I want to test in terms of the hardware, in terms of fit and finish before I start adding the thing stuff in the cat. Chief among which is actually have to do with the fact that the bed need to be here. I need to know where the two head is relative to the bed, and that's going to be what I'm up to today. So at least for the first half, if not more, of this stream, I'm gonna be putting the bed together here, and yeah, that's the plan for today. So I am going to I'm scrolling the manual right now to the section where they said I mentioned the bed. I'm not even gonna plug it in. I'm just gonna put it in place so that I know where everything is. Ah, there we are. Alright, printed the page 139. Is there any special notification here? Notice here from Aereo on that page? Oh, remove the pressure from the bed after applying the magnetic sheet carefully. Yes, the next page over. Remove the protective plastic film from the bed after applying the magnetic sheet. Carefully trim the holes from the mounting of the bolt of page 158. It sounds like super stupid. One second. I thought they already cut the hole out from me. Let's check out this bed now. Yeah, they already cut out the bolt. Oh my. Yeah, you can see they cut out the holes already for the bolt to come through. So I don't know what they're on about when they said to trim the hole for it after applying a magnet. I assume it's just part of the manual. Anyway, this is gonna stay on my bed so that I don't have to open that box again. I'm using it as a, oh, no, actually I can do this. And the bed stays safe in there. And the laptop gonna be on this piece here so that it doesn't overheat. Really should not buy an Intel laptop for things. Was not the best. It was not the best decision of my life. I tell you that much. Oh, and so the machine. This machine lost connection to the internet. So at least it's on the print now, so I don't have to be worrying too much about it. Alright, so, where was I? Yeah, alright, let's go check the menu here. I pay 139 and 140. It's all about the magnetic sheet, which should already prepared for us. So I could skip in 140, 141, don't need it. 42, don't need it. 142. 43 doesn't need it either. Electrical, I don't do that just yet. 144. Need this? But I do need to make sure to keep a note to go back and delete this page. We don't use that probe. Yeah, the 144 is about the Z probe, the traditional Z probe. Alright. Time to use some of those Edio printed parts. See how that goes. That one is for the bed. 46, 146. That definitely had a page somewhere. And there we go. Let's put a right there now, son. The wire guy with specific printed font detail. Okay, that's sometime later then. I hope that I don't have to glue anything in here because I'm gonna put this on again. Frame extrusion will vary from 175, 75, 300 mil, 200 inch. From the edge for the essential extrusion. Alright, let's move on. I guess this come later. Let's do this guy. And 5 by 16 on this thing. That is a hole there. Oh, 100. Oh, we're doing this again. I'm gonna have to center this damn hole. Okay. Mm. Oh. Man. More, so it slides more quickly. I'll leave this. How we do this? Okay, measure. Oh, I got this thing. Just grab the phone, put it over here in case someone contact me. There we go. Now, oh, got a chat. One sec. Yeah, I have a hard time reading the chat and all of that. Because what is it? Oh my god. Evening. Oh, no, actually, this makes this really confusing. What I'm gonna do is what I did last time, where I put the chat on the side, the documentation. Okay, there we go. So now I'm gonna read chat and read the documentation at the same time. What a genius. We get 200. That was easy. It wasn't 200, so. I bet it's a bit of the toasty side in this heat next to the printer. Next to the printer? Not really, because I'm testing out something new. I am having a fan running on the other side of the room, just generating some airflow around the place, and it's turned out to work out pretty well. Inside the chamber, though, it's 52 degrees Celsius, so I'm still reasonably happy with that. As long as it's not above 65, that's the point where you go a little I may got some trouble doing that. Yeah. Yeah, I thought it was going to be an easy job. This is 200 short. Oh, the 199.5 is what I'm aiming for here. Okay, no, man, I take it back. That's 200 short. Anyway, that's it. And of course, I need to make sure that it's square. Problem solved. I don't want to pull the box like this, but I feel like gonna have to see. What's going on, but I don't remember the aluminum extrusion on the sideboard twist within around the bolt that this much. I mean, it's not bad, but oh, I'm going fireball. I'm gonna put a cam on it, that's for sure. So, is it managed to problem already? Alright, that's 199.5 right there. Alright, it's perfect. This is perfect. So just leave it at that. Don't touch it. Touch it. Touch it. What else? What next? Next. Alright. 3 not 2 on the side. And 5, 2 and 5. 3 and 5 out. So I think I know what's good. Yeah, I know what's up. I'm just gonna do it. So I need 3 and 3 knots. Bring the T knot. Yeah. Oh no, this is M5. So for M5, I need 6. And 3 of these. M3. Orientation matter? I don't think so. For the M3 at least. For the M3 that doesn't matter. But for the M5... For the M5 is inner then outer. Inner, so it's pointing inward at the, and then I put it outward at the front. At the back, it's all pointed that way. Okay. I might not matter or not, but I will follow the menu to the T. So I'm gonna find a mic that is both can record me while whispering, or simultaneously let you guys hear me when I speak loudly. This side to M5 knot. You should. And the more I look at the screen, the more depressed I get. I don't know why. The screen here on the gantry. I was expecting it to be something like this PET sheet they have, which is dark green, more like this look cool to me, but this like the pale green. This stuff look lifeless. Good. Why I have a laptop just there just now. Wow. Alright. It was right next to me. What's the orientation mount on this one? I don't think so, but I'm gonna put it like so. That's the inward pointing. 5 on the M3. Oh, where's the M3? M3. Oh, the M3. Both of the hole pointing inward. Yeah, sure. Pretty nice. Alright, so there's nothing here. Nothing's down this one. Okay. About this, but M3 are easy to remove, so I'm not too bothered by this. Okay, but that is M3. M3 with this. Stop that jet. Give it a soft landing. Oh, and the component is in the box. I need to grab that. Good time to move my leg as well, because my hand. The Japanese sit like that. That's for hours. My body ache. My neck aches the moment I sit like that. Just what? 15 minutes? Okay. That's Vietnamese like to sit like this with our legs crossed. Guys, that doesn't look like an. Alright, fine. I'll take that word for it. No. There seems to be 2 extra holes here. There seems to be 2 extra holes on this Wago mount in the middle there. So I think what they want us to lower us to another 2 M5 T-nut into the gantry. You know what I'm not gonna do that just yet. It's easier to load those in than it is to take them out, especially when you cannot just slide them off the end. Right straight. And we're looking for M3x6 button head. This guy, right? Bullseye. 3 on each bearing. So 6, 9 in total. Okay. Remember when I was once a bit paranoid about carbon fiber thing? Yeah, I remember. These are what? GE5C, made in Japan. These are quality stuff, honestly. Yeah, these are pretty high quality stuff. That is really going down beyond what they can tell. My voice got muffled just a second ago. I don't know why. A pair of parallel pliers. Go. Do not touch the bearing in the middle. That is the bit that needs to spin. We're not putting much force in here either. Because it might be a tight fit though. I want it flush with the top. That. What is wrong with this water sound? Okay, hopefully this don't peak. Oh. Yeah. This will keep what it is, you know? I'm gonna reset that really quick. Yeah, so. Keep that. That improves the sound just slightly. I don't know what happened, but what is it? When I started, the mic was very very loud. So I have to lower the volume a little bit. But now the volume seems to be stabilizing. Yeah, let's go up and down a little bit every time. Hold on to the chat. One of these things, actually, when I got my paycheck, I'll buy some a better mic. Not sure I can justify it though. I need to clean these. So tight. I'm gonna spray just a bit of what's it? Oil into these when I'm finished with them. Oh, this way. Then I lost the boat. No, I didn't. This is another job for the bolt point. Yeah. Smooth transfer. Should say. The plastic here if we carefully ruin the plastics. Alright, I need to swap the mic back to the old mic, but this one definitely not working too well. And I'm just grabbing on the table there. Oh, we have a backup. May not gonna like this. Oh, that's not that bad. Okay, okay, I'll take that. Right. And if there's a single ambulance running outside, the chat will be completely dead. Everyone in chat gonna be completely dead. Let's see what really should not be configuring stuff when I'm. What's up? This these M3 button head peanut barely touched the edge of the bearing. I know it's intended to be really loosely touching, just enough to keep it in place, but that concerned me a little bit. That's alright. Okay, swap up that one with 2 and 5. 4, 2 on each side. The bolt, right? The bolt, this bolt here, right outside. No, I still haven't. Still partly worried about the annealing of the BETCF. I haven't done it, that's for sure. I don't think I have a practical means to do so, and I really don't want to be bothered unless I absolutely have to. Oh. With that said, we need a little bit of grease. I got some spray-on silicone grease here. Gonna spray onto this bearing just a little bit because they're a little sticky. Oh wow, I get noise here. Yeah, the loop just done it wonder. Immediately improved. Good. don't use this paper tool before. So these need to be alright. Good call from my end. Then go for the other piece as well. Oh, that's not where it's supposed to be. The cardboard need to go to the recycling. The one. The same little test here is the same one I put on my computer on. So any dirt or grime coming on there need to go up, or else it's gonna get stuck into my laptop, and that's not a good idea. Especially if the dirt grime is actually metallic. Okay. And 8 by 16. Come on. Alright, this done. Oh, 31 degrees Celsius in the room. Feeling every bit of it. How do I put this thing in? Trying to lower the gantry so that I got more room to work with. I don't see much of this. The strange thing is, even this mic, and without the filtering, I still lost some of my voice. Still got cut out of the stream. Also, really, I forgot that I greased this rail. No, this that's it, lead screw. And now my hand is filled with grease. Yo. Yeah. Loosen, retighten, slightly loosen the bottom of the bed frame with the printed part and then gently shake the bed frame before retightening them. Yeah, I'm way ahead of you. I don't need to do this. I don't know if it's on stream, but what I'm doing is I just hold the foot driver right there. That's the position, and I just twist with my finger. That way you cannot overload the bolt, break the penny part. Just a little play in it. What about this stuff? A little, yeah. Talking and edit this down, so don't let anyone was wondering. Holding the X driver in a particular way where I cannot generate much torque whatsoever. What I'm doing is just giving the material just a little time to settle it in and just tighten it down where it needed to be. All right, let's put the bed on. Oh, so I take it back. Oh, Oma, this goddamn printer is super hard when I just lean towards it. No, I have to touch it. It's right here. Not touching it, but it's so hot. So M5 peanut and the Trident bolt. The bolt is M3 by 20. The strange thing about these Do I want to follow that guy? Let me try some. Certainly, putting the bed in is always, no matter what Voron you put, it's always annoying. Very annoying. Want to try some M5 by 25 first? That is something I want to try. Some trick that I picked up when I was making my 2.4. Relevant here or not is up to see. Still out. Oh my god. Oh, just so you know, I'm putting this in just so that I can test fit something, and then as soon as I figure out what I need to test, I'll take it off because I am not picking up this machine with the belly on. Boy, it's so heavy. And this is the time where I may end up scratching the aluminum extrusion. Damage. Heat up it though. Nope, M3 by 20. Alright. Yeah, I don't like how these beds are simple. Always felt like this is an afterthought. And it just never go away. That's it. Also, I gave the computer just enough time, so I reckon I'll check again to see if I can enable the noise cancelling. Oh, I have a habit of leaning on the side of my machine and watch it when it end up with the headache from the heat. I've learned eventually. You'll be surprised. It wasn't too long ago when the best of us always have the habit of just putting our face right next to the printed part as it's starting the first layer or something. And yeah, that's a bad idea. That's a one-way street to just like box and microplastic up your nostril. Yeah, so what's going on is that the headphone that I had been using to have a mic is no longer picked up by the software that I'm using to kill the noise. So a little bit. Oh, there we go. Never mind. It's right there. Just give it a moment and it'll sort the stuff out. Alright, that's the noise cancellation on. So all the popping noise won't popping in anymore. What was I doing? Yes, and 3 by 20. 12, 8, 10 by 40. That's one. Back lay down. Right. What is that? Oh, what? Oh, there we go. See it. 3 by 20. 3 on. Oh, I only got 2. Brain not working today. No, I'm trying to scrape the bottom of the bed with the um with that aluminum extrusion. Silicon mat is already installed. Okay. I do have to say with this it's so much better than the V2 2.4. There are only 3 of them. On the 2.4 there's 4. Managing them while coming in is an absolute nightmare. Gosh, ready. Don't go that. Alright, shall we try this with picking it up? I know I make a statement of that I won't pick it up without with the bed on. But then now that I said that, I just like, okay, how bad could it be? The young backs can handle it, right? Poke it down really quick. I don't, because I need to move it around, so pull it down for now. I'm feeling a cross at the back. I wanted the back. So. Not that big. Alright. Where was I? What was I doing? Yes, let's try this. Okay, with your legs, not your back. Oh, exactly. So like when you do that, yeah, just don't tilt it over, because what The palm nut here that is used to hold the bed up. They are lowered down by gravity. So if I flip the bed over, there's a chance that the printed part got ripped apart and the whole bed just fall forward. That makes sense. Anyway, the whole point of me doing this so that I can load up a nozzle here. I need to put it the cartridge. Let's see if the x-carriage that I designed push the two head too far forward and actually missing a lot of millimeter or two of the bed. And I need to lower the push bed up to do that. So I'm going to grab some. Oh my god, it's roasted. Some silicone. Now some gloves here. I think I can bring the camera down, can I? I don't think I can bring the camera down. I'll bring it down when I'm done with the adjusting. Screw it up. Oh, I think I'm in the clear. I don't believe it, but I'm in the clear. Ah. Well, okay, I am sort of in the clear. Sort of. Hey. That. Grab the camera. Also, here's some tip for those who want to reuse their gloves. Always put an X on the side that you don't, on the outside. That way, when I put them back on, I don't put my hand into a glove filled with, on the side filled with grease. Also, if you work with high-sensitive material, don't risk it. Just get rid of the glove, get a new one. wait. So you can see there, it's touching the edge of the bed. Really, just touching the edge of no. Yeah, you can see it, right? Yeah, you can see it. It's touching right at the edge of the bed. It's not perfect though. So let me just move it to the front really quick. Give the wiggling around. Yeah, and this one touching too. Yeah, I don't think you guys can see it very well because of the light. The lighting is against the camera there, so let me just... Yeah, so yeah, you can see it land right on top of the bed, which is good. Put it up. Put it to the side here. Wait. Ah. That problem. That is not fully aligned correctly, I suppose. So that one is the 00 is not on the bed, so I don't really think not particularly thrilled about that, especially when in the new design I pushed it to head forward 0.5 millimeter. But not too bad. Not too bad, I don't think. We can reevaluate this in due time. And well, that's good news. That means, well, that's good news and bad news. The bad news is that means we don't have that little sliver at the back. We don't have that little extra bit at the back where we can just put the wiper without interfering with the print volume. But that also means I can, but that we're not losing any volume in fact. So yeah, the space that we lost is literally the space that was meant to be was it? What do you call? Was meant to be like a some tolerant for the bed to be anyway. So we don't lose any space on the bed. Right, let's lower the bed down because I don't like to get this gantry to be this tall on high top, for one. And for two, I need to work with the Z axis, so I need this bed to be lower. hope I don't have to do this too often. It's tedious lowering this bed by hand. Oh, back to the normal angle here real quick. Let's see what I'm up to with the bed, up close and personal. Do we take the bed off? Yeah, we'll take the bed off. I'm not risking my flinging this around. Too heavy. The bed on. Alright, let's take the bed off. Well, I see. Look at that. Oh, don't flip the camera. Much over the magnet already. Oh, good thing I turn on the noise cancelling because there's an ambulance just run past. Alright. Alright, putting things away. Oh. Okay, so this bed is great. I'm gonna put it over there. I'm not gonna touch it for I don't know how long. Until I'm finished with the x-carriage. Oh, right. That's that. How long have we been streaming for? Huh? Oh my god, it's hot. It's hot. Right? Laptop is hot. Ah, 1.5 hours. Exactly halfway through. My timing is impeccable. Okay. I really don't like the use of these to mount the bed. So anyone kit maker out there, for every kit maker out there, these M4 thumb thingy here, pretty sure the Voron team just picked this to mount the bed because that's whoever come up with this idea came up with it because this is the only thing they have laying around. If you want to add any value to the Voron kit, then your kit, please redesign this. Mounting the bed to the gantry is always the most annoying bit of everything. And it will always be the part where someone's gonna scratch something on their kit. Yep. Because that bed is always the most heaviest thing to maneuver around the kit. And yeah. Where was that? All right, yes. So, well, I was checking there before for the people who missed that point. I was checking if the attachment that I add to the x-carriage here. I was checking if this x-carriage is gonna push the two head too far forward, for it to be fully utilizing the bed area. And the answer is sort of, but not really. I think I lost like a millimeter short. Not too bad. I am not gonna lost sleep over that. I think the most of the space lost was lost of the additional space at the back of the bed that was meant for the original Z probe at the back, the gantry that are in here. So that was not much of a loss. Basically, we're not using that anyway. But what that also means is I cannot just mount just solidly mount a brush right at the back here and hope for the tool that's gonna pass it, get it self-wipe. I have to come up with a mechanism to let the brush come into the build volume and then retract so that we can preserve the spill space. One of the things that I am annoyed about this V1 right now is the fact that the brush is built into the dock, and that is a big problem because even if I can put this away real quick, even though it's a single material print right now, I am still doing putting the dock in there, and the simple reason is because I want that brush dock. I want that brush to be in the space somewhere so that I can scrub the nozzle after every print. So the brush being built on the dock seemed like a good idea at the time. It seemed like an added feature for my for MissChanger, but in the long run, no, it's not. I want to have a dedicated docking system, a dedicated system for the brush that is independent of the dock, so that I can take the dock away, regain all my build volume, but retain the brush. So that's the idea on that. I do have some idea on how to some cool ideas on how to get that done. So do look forward to that. But for now, we need to go and go back into the cat and fix this thing here. So yeah, let me just turn the camera around to the table. No, actually, I'm gonna put the camera on the printer so you can see what's going on the bed. But then again, I spare you off the shot of my crotch. I'm going to clean up a bit and then put the camera on the print. show you some of this. Enjoy it. I threw this back away too early. Let's put the mounting in the bed. Alright, this is for me laptop. You know, it's now part of an experiment. Yeah, and also the absolutely settling in on the what's it called? The ow, my lord, my brain bug out. The two chain mechanism definitely soften up after a couple of initial burn-in. Oh yeah, one of the things that I noticed that I need to do is that I need to reduce the how much indent this screw is, because it was poking out on the other side and it can scratch my front panel. Last of it. Oh wait, no, there's this. I still don't know what the sandpaper is for. Like, it's nice to have got some sandpaper, that's for sure. But what they for? Oh, this is going to the box. So I'm constantly paranoid, maybe just walking out the door and scrape myself on this short aluminum extrusion here. Haven't happened yet, so I guess until then it's just me paranoid. Okay. All right, now I can turn the camera up so that I can relocate you guys to the desk. Hopefully the oh wait, no, what I'm saying. Totally forgot. You get to see what the print is. Yes, and I need to turn the lighting situation on this one. Okay, let me turn the avoid stroking there by turning the daylight all the way up. If I know where it is. Right. Then this is the time when you go, oh, I want access to my my web interface, because I don't know what to do with this. Station D. Light pin. Alright, pin, daylight pin. There we go. Yeah, I'm trying to. I was looking for a way to turn the light all the way up so that the you guys don't get to see the PWM flickering on the printer. Alright. That's it. Going to turn on the camera. Let's hope. Quick. Làm ra tin vào to turn the fan off because noise cancellation went crazy. Winter is common, chat. Oh. Oh, this guy. Oh, we need to edit this guy here now. Oh, you really don't. It doesn't show at all. It doesn't show at all. But I increased the thickness by 0.5 millimeter, just so that the bolt doesn't scrape against the back bits. Also, I chamfered all the surface where it contact the bed, that we don't get any more elephant foot. Honestly, what I should be doing now is to go to the printer and recalibrate 2-head 1 for ABS, because I forgot to save the setting, and before I move it to PETCF. And now it's the PA on that, the pressure advance on that thing is not exactly good. Anyway, that is this. This one is I think this one's done for the most part. I just need to print it out now to test it. Now the hard thing to deal with is this thing. Oh, let me just before we touch this, because I know for a fact that what we're about to make is one of the base sketch on this. So I need to check if I had already made a copy of it. Yes, yesterday at 11 p.m. Alright, so in that case, I will just put these away now. Because they most likely all gonna be broken for one. Oh, okay. Put this entire one away. Put stock back in. And I'm gonna hide something that I know don't do much of a problem. Alright. Yeah, we want this clamp here. So we hide everything. Gate. Bottom of the sound. I know what I do with it. Oh, right, yeah, because this bottom is the bane of my existence. This is the key to almost 10 out of 16 of the above pre-catches came from this one. Oh, let me go grab some water before I continue. forgot I made tea. So I'm gonna have enjoy my lukewarm tea now. If you excuse me. Yeah. To focus on the printer. Got me tea. Crime against all British. Okay, where was I with this? Yeah. How did I do all again? Okay, that's good. Good. Oh. Also the top comfort. Yeah, so what I was saying yesterday, I want to push this up and that one down. So you cannot push that one up because that one is linked to that hole there. This is where the rod the rod that go across the dock lies. So you cannot edit this distance for sure. So we have to. Wait, no, take that back. Let's go back to we'll deal with the base first. We'll deal with the base first. First, we need to make sure that the what do you call the little bridge on top there is sorted in terms of how well it's gonna hook into the print to the two head. Right now, it hook a bit too good. So make it slightly looser so that the two head can fall into place. Alright. Also, I want to delete these square here. They were there to facilitate the printing on the side. We move away from that. What is up to? Hey, if it start making spaghetti, make sure to notify me. Oh wait, okay, yeah, and one more thing. What the hell is this? Alright, this needs to go up, that one down. What is keeping them on a line? Oh, there you go. That's number one. We're on number one, so that one now up. Oh, wait, what? That one can go down. Wait, why is this 1.2? Oh, I got it. I remember. That's the. Oh, shite. That's the gap needed for the nozzle plug. But that one cannot go. Another one cannot go. That one cannot go up. This one this one can only go down, huh? I want to give this one 1.6 at least. 1.2. So 3 walls between that pin. Oh. Alright, so this is 1.6. 1.5, so it's not too bad. Let's hope other optimization can help too. Oh yeah, I need to drop that from 3.6 to 3.4. 3.6 is too big. If I really want to go fine, I can make it 3.3. That would require almost everyone to drill it. Actually, let's go for that. So the idea here is no 2.3, 2.2. Let me get 3. Oh yeah, so if I set it to actual exact 3, this gap now is 2. Oh, so I can increase that by decreasing the hole. And in fact, in reality, the reason why we wanted the reason why we were giving it so much space in the first place, this hole is printed vertically. So it's not exactly a hole, so I was giving it space so that it can, so we can still fit the rod through it. But then again, I can always instruct people to just take a drill and clear out the hole, right? So I think that was it would be a reasonable thing to demand of people to have a drill bit at least. Alright, I need to make a sketch really quick. I need to make a sketch. Thanks, what? I need to sketch. Alright. So, let me sketch. Create a new body. And okay, so. So, I know how to do this. And sketch with the object. Film attach. That is Z, Y, Z plane. Like that. The reason why I want this now is to deal with this simply here. I don't want to touch it. I don't want to touch the assembly at all. I just want to start putting things down. So this is line number 1. Line number 2. No, because one of the things that I noticed that the dock is doing is that it pushed the tool head all the way up. So basically the base, so between two extreme of the mechanism. Let's go all the way up by 13 basically. And it shouldn't be. I want it to be only going up by 7 or 10 millimeter. It took 5 millimeter to disengage the mechanism now, because now you don't have to account for the distance of the Voron tab rail. Now I can't envision it. I'll take back this. I'm trying to backtrack on how exactly did I figure out the distance that I came up with for this. I can't remember. Between the two ahead. That's fine. Alright, guess what? I don't remember how I got to this number. What I do know is I want the whole thing to drop. A sec. Go grab. What's the ruler? Yes. Awesome. Oh. Yeah, so I'm not gonna change the camera view right now. Yeah. Ooh. So I'm going to push this up 5 mil from where it is placed, and see how far down that was, where on the extreme top of the impact. So yeah, so 5 mil down. So what I'm saying is I need the dock to be what, 5 mil? No. Two head relative to the dock need to be 5 mil different. We got up 5 mil like that, okay. I'm saying. What am I saying? Oh, I'm just, you know what? Actually, let's zoom in on the camera. Dude, there's some thinking there. That's that. Oh yeah, I'm totally not going to reading any chat here because I need to think. I am stuck. Anyway, I absolutely cannot remember how I came up with the number 98 there. The number of 98 for between the base of the stock and that nozzle. But what I do know is right now this is going up. This dock here, when it's fully up positioned like that, it pushed the two head up too far for what I needed. It pushed it all the way up. Yeah, so it pushed up. You can see that there is a stop point where the back of the bottom bit of the pin here slam into the top bottom of that top there. Yeah, that is what happened right now at the peak of the docking position. So I want the whole thing to come down a few millimeters. see that. I need on, well, not a few millimeter. By few, I mean, let me grab my ruler really quick. I need to put the camera down because I cannot do this on camera. Well, I can do it on camera, I just cannot hold the camera. So it needs to come down around I can't see what I'm doing. Oh, damn it! I was looking at the inches. That's why I was like, why that make no sense. All right, about 4 millimeters. So I want to lower the distance between the nozzle and that place there by 4 millimeters. So that's what I'm gonna do in the cat. So go back to here. Here. That is in there. Now to be increased by 4 millimeters. 1, 2, 3, 4. Like that. That's going to be the new distance between these two. Is that true though? I'm trying to think in case I was wrong in some place. Is there definitely because oh, actually that wrote that down, the old number 98 minus 98, right? 58. Is there a reason why one would want to do? But this is it's too risky. Too risky to do it just with like this. I'm gonna reset that. Okay, so okay. One second. I need to check. I use the undo tool and realize really quickly that might not a thing to do. No worries, I did break anything. So get out of the way. So what I'm gonna do now is I'm gonna create a blank document so that I can testing out. Use stick figure. For those who was there was one guy, one lad who was asking if they should be starting in the CAD or should they be just started on pen and paper. Here is the alternative for you. Start in the CAD, but you draw as if you draw on a pen and paper. So imagine that is the center point of the dock bar, the bar in the middle of the block, at the bottom of the dock to like that hold everything together, and the clamp into. So this would be. Alright, I just cannot talk to myself, so I am taking my headphone off and just pop out here. This would be the inner column that push the inner bit of the gate, the dock up, and this one is the outer column that put the outer bit of the gate up. These two need to be at same length. Same length equal, because we want a smooth transition between, so that lock this point in first, and oh no, you cannot lock. Okay, let's grab these two now as construction line. Now shall block that line in just for now. Now, the reason why these two need to be of equal length and parallel with each other, so that it cannot move back and forth like that. The relative angle of this line here is the same. Not relative, the absolute angle of that line is the same. And the top max position here is the tippy top position of this is there, and I need to draw some circle here. And that one is not. Oh, the signs. So putting the top matter with this circle. That line and that line. That line, this line here, is represent the how far the two head gonna be pushed upward, right? So if I dimension that, I give it, because the maximum, the length of the bin itself is 5 millimeters. No, that's for a fact. So, but obviously we don't want to accidentally go too short, so we make it a 6 or maybe a 7. Alright, things start drastically increase in terms of size, no worries. And because that length is 7, let's put it there. Like that. So that means, okay, let's lock the length of this in. I think this is 11, right? No, okay. How long is that again? How long was it in this one? Again. Like that really quick with the pillar, inner pillar back on. Now let's do some measurement here. Close that. I don't know what I was doing there, but I did something there. Do not want to touch it. Alright, bring back that pillar. What was the distance between that and that? So 25, this one. Yeah. Oh, it was unexpected. No. Set, close that. But these were 25. Oops. Wrong button. Station. There we go. These. Ah, close. 25. 25. Like that. Right. The why is it locked in place though? No. Oh wait, no, because this is the downmost position. So when it swing that way, it's gonna go up. That one will be there, and that one will be somewhere up here, basically. That's not the problem. So 25. And the thing that the ultimate thing, so first and foremost, this reducing is not the problem really. Or even on this current version, it reduce it's not ideal to go that far up, push the two head that far up, but ultimately that's not the problem. The problem is actually this thing here. Let me just draw that really quick. Yes, this angle is the angle to which the force that is translated from the xy plane toward the z. Okay. Right now, I think actually I can do this really quick. Right now, it's something like this. Right now, it's 60. Right now, 60 out of the 90 degree that there is available, 60 degrees, only 60. This angle being 60 degrees mean that about what? Only a third of the force that is generated from the gantry is actually used to push the dock upward, and then the other 2/3 actually act to push the dock forward, which is why what happening is that 2/3 actually flex the dock bar, the aluminum rounded bar that we have. So that's not good. So now I just want to reduce it to 17 to 7. That now reduced to 40. So 40 around close enough to 45. So half of the energy that is used to push the dock, the two head, is now going to will be used to push the two head upward. No, at least push the mechanism around the center there. And yeah, so I hope this gonna at least so it's easier for the machine to push it. So we want to keep it definitely below 60. 60 didn't work, that's why we are even here in the first place. I appreciate that I'm blubbering. Trust me here. So one way that we are going to reduce this angle here is to do what I just do, and that is reduce the amount of height that we demand of the system. But if we keep this one the same, that is the equivalent of the current dock just being dropped downward a bit, just lower a bit, just lower via the spacer on the bar end, lower them down, and having a starting position up there rather than down here somewhere. That is one way to do it. The reason why I keen to not do it just yet is actually, so let me just put this to 13 really quick. And that. The reason why I'm not keen of this specific I'm not keen of this solution of just reducing the height there is I'm still having hope that this is I don't want to redesign the bar end, because that bar end is the same that is of that of V1. So if that bar end function as is, then that means the Stealth Burner can have a chance of being fitted to V2. That's the idea. So I don't want to have to redesign the bar end specifically to V2, even if that means just to redesign the spacer for V2. There are some space left I can just use, but you know, don't want to go too far. And also pushing the dock downward mean that there's more likely of collision between the front of the dock here with the bed. So the other solution, I would say, if I lock this in, cancel that. So if I put this as 7 now, no, okay, so I'll do this as a reference, okay, lock that in as 45, 45, and If I lower this number down to 20, no, right now it's 7, yeah? Can I still increase that? 6. 21. Okay, I was picking it out my ass there. So what I'm doing here is basically I want this attack angle to be 45, but while simultaneously I want to reduce cancel reference. Okay. Put that a reference. That's 7 again. 48. 48 is still too steep down. 6. Yeah, we go for 6. See how that goes first. Oh wait, no, we need 7. We need 7. We need 7. And if I decrease this one more, oh, that's 50. Wait, so if I increase this, it goes up. Alright, so what I'm looking at here, then that means the longer this action arm is, the less steep will this approach angle is. Okay, but whatever, no matter what number we want the total height to be. 23. Do you want it to? Oh, in case anyone wondering why it's 7 instead of 5 or 6, it's because the hook onto the dock that is hooked into the two head is 2 millimeters. So we need to go down an extra 2 millimeters so that to clear the hook. Alright, so put headphone back on. Okay, so let's go back to this now. I have to drop it that row. Alright, let's go to the printer. Let's mess with the prototype. Okay. Finish the camera cable. That's stupid. Okay. Okay. And I need my extract. Ow. I just slammed my hand against the bed. Okay. So I want to drop this top position down by what? To the until if we reach until the pin here reach that bottom there. Why is that moving? Oh, just stuck. There you go. Down now. Oh yeah. Oh wait, no, so. Oh wait. So I actually might not need to do the part, huh? No, I was worried that the adjustment bit, that spacer bit here, does not give enough give a good enough range of motion. So which means I would have to design this somehow to redesign the dock somehow. But it seemed to me that I can get away with it. Okay. Oh my god, I'm worried about scratching my brain. Alright, just a little more. Alright, so just hovering about 2 millimeters above where it's supposed to need to be now. Got in. Totally accurate. Not totally accurate, I see. Alright. Oh, that. Oop, actually still quite high. Doesn't pay attention to the movement. That's good. Oh yeah, it's stuck. Okay. Yeah. Prop it up. To artificially prop it up by a couple millimeters. Simulate it new position. Start looking up. Still not working. That worked. I think it's this thing. Oh, that's good. Yeah. So because there's a hook in there, so that's where the little click can come in. Now I'm just gonna pull it forward, just sideways. Sideways. Yeah. Try it again. Oh wait, which one is which? I'll show you. Oh, this is. I need to it go up. It need to be upward about that much more. Let me try the next one here. So basically, that is 5 mil in terms of like. This is 5 mils in terms of shoulder stroke distance. This is 6. This is 6 stuck of the hook. The 6 mil is basically 13. The total length between these two, the minimum and the maximum point of travel is 13. So if we deduct by 5, we just got what we just got. Now 6 is seem to cause some trouble in terms of latching on, because there's this little hook in the back of the gate here that not allow this two head to go all the way in. But once it's in, it go up very easily. Oh, and the thing just got off. Oh, this is not 6, it's 5.5. But the 5 seems to be the magic number, huh? Yeah. I don't think you guys can hear it, but there's a nice click of the two head docking there. Yeah, and I can push it. It doesn't seem to be able to slide to the left, the right for some reason. So I drop now. I think I adjust this by. Oh, wait. Try that again. The current on that gap need to change. Current on that gap need to change. I cannot push the dock into place when it's on the top. I need to chamfer it a little bit or something. Yeah. That's what we want. Output. And then again. So yeah, this is 5 mm of thickness. So if we push the dock, push the block up relatively, up by 5 mm in. Yeah, I can actually do that. I don't like how violent that is still though. Alright. Maybe I do it over here. That would prompt it up by do something. And this will just fall right off. Alright. Yeah, the side swipe is not exactly sorted on this one. The side swipe is not yeah, the return is easy. The intake is not exactly not. So again, basically I keep doing this over and over again so that I can see if I can spot any new information. So yeah, so right now the problem is I cannot swipe this to the right to lock it in place, so I just keep falling back out. Yeah, the two head would fall off before I could even before I could lock the dock in place. Pick up this. The pickup is minor. Interesting. So first of all, what's interesting information? 5 mm seem to be the magic number. So 13 minus 5 is 8. The reason is actually nothing to do with the position. It's actually to do with the little latch I have in there. Let me show you what about. Yeah, to do with these latch here. They hook it all up to the bottom of the two head here to get it in place. I think it's 2 mm into like in like how much it protrudes out. And I think I should reduce it by, I don't know, 0.5. Yeah, I think I could reduce it by 0.5. I think. Yeah, that's what I want to do. What I'm going to do is I'm going to just cut it with a knife now. Because this is a prototype, so I don't mind cutting things out. Okay. Alright, so now I've used the larger 5.5 rod there. Become much tighter. Yeah, and it's now engaged. That's good. And I can push it in with less viciousness. Is that the right word to say? Yeah, I might. Alright, one of the things here I'm thinking. If it's shown. You can see that. That is where at the back actually a contact with the top. So I'm thinking maybe I can create some sort of attachment right there, so that the back actually connected to the top, and move that directly instead of relying on the two head to do that. Can I trim the dock really quick? Oh, I can trim. Yeah, just shampering it with the knife. Right? Why won't you move right? It moved right yesterday. It moved right yesterday. Now it doesn't. Why don't you? Ah. Here we go. Roll up and go. Oh, that one worked. That worked. There's like a magic spell that I do by just waiting. The machine just decided that it worked. Yeah, I know. There's a specific. I think there is a. let me try this. Oh, is that? Oh, the magnet is too close. The reason why it got pulled out there, is because the magnet between the between that and that magnet, between that magnet on that they're too close to each other, so that they give enough each other. The force is just enough so that it can keep enough to pull the two head out. I don't know. So we need a way. Yeah, it wasn't like that before because that little tube inside the dock, little tube in there, is enough to just hook on this and keep it there intact. I think when I add the magnet and under the LED hole here, it should be improved. I reckon we just hope that that's gonna work. So let me try something here, just in case not well calibrated after all the moving around. Right, that's a temporary thing. Lock it in. Oh wait, I think about it. I should be able to. I should create some sort of like screw actuated a little bit and stopper down the bottom of this dock, so that I can screw it in and that dock gonna be pushed up. That's just a passing thought. We're not dealing with that just yet. So now I'm going to go all the way in. So that's just all the way forward right now. And I'm just gonna slide to the right. Huh. Guess it was just a matter of was it calibrating the dock. Alright. This is good news, chat. Does this mean that the only thing that I need to do, the only thing that matters, is to raise the bottom of the dock up by to raise whatever stopper here, to add a stopper here, to make sure that this thing is about 5.5 millimeter taller at the bottom, and that's it. Well, definitely. Maybe 5 millimeters, 5.5. 5.5 is too steep. What is it? So I'm just gonna try to do it like a machine would do, and that pull it slowly instead of have it just jump on me. Yeah, that's a lock. Yeah. That's good. Disengage with that. Oh, that does not sound good. I want to wrap this tool head a bit more. I want to wrap around it. It's barely good enough what it is right now. Here's a better solution. Okay. Maybe. I'm just gonna try grabbing the top on the bottom here. Remove that instead. No, because I'm thinking I could build in some sort of yeah. Alright, so I reckon I can build in a little protrusion here so that engage with this this wall on the dock side here, on the rail side here. So that way the gantry itself will actuate the dock instead of trying to actuate the two head, which then actuate the dock. Yeah, let's go with that. Alright, I think that's it. I think that's it. I think that's my final answer. So I think we got lucky with the what is it called? The height of the relative height between the dock bar, which is this bar down here, versus the two head, because there is just enough space in the bar end spacer to lower the bar low enough to allow the dock here to go up at a more gentle angle, so that it doesn't go and it doesn't get stuck. So I think that's the plan then. Plan then, therefore, is to not mess with the dock bar, to not mess with the dock, but rather to mess with this base piece here, to add some notch into it to allow it to interact with the rail side piece. Yeah, to interact with these two here, little dimple, and be actuated without the need of the two head. So imagine something like that, yeah. Yeah, so it just needs a little dimple in there. Yeah, so you can see the butt against each other, so have a protrusion on the dock here. The gantry can be used as the thing to push the dock sideways instead of pushing the two heads sideways, which then push the dock. That way, it's less finicky that way. Oh, just to revise, add the little knot there for sure. Reduce the tolerance of the pin. Because that last one I already done, but I'm gonna really have to redo it because now that I found a new solution, I'm not gonna trust myself to not to revert what I had end up already done. So I will reload the old save. And edit the part of V1 of Z0.8. Anyway, I think that's it. That's a lot of thinking and not a lot of doing, so I do appreciate it's a little boring. But that's how the things tend to go in terms of progress of this kind of project. You can change it even if you want to. Right. And with that said, we have hit the 3-hour mark. So I must say, for all of those who stuck around for all this time, I must say you are a very strange person. And I myself have to admit, if I were to log on to my own stream, I would be very bored. Not fun doing something. No, it's not fun to just watch like paint drying. Basically. But anyway, we're 3 hours in. I don't have much energy left in me anyway, so the next stream would be on Friday. Oh my lord, it's stringing like hell. I don't know why. You guys see it on the stream? It's string as hell, but it's not gonna fail. I think it's fine, but it's stringing like hell. The that piece. Whatever. Everything is a prototype. Time to starfish and cool down. I don't know what starfish is, but yeah, cool down indeed. I need to get out and get out of this formal clothing so that that I wear so that I can be on stream. I need to get some pajama. Cool myself down. Turn the fan up high so that I have all the air flowing on my face. Ah. I'm gonna delete every progress into the CAD that I have done today because I need to redo all of it to fit what I have found today. Fortunately. Ah. Okay. But with that said, I thank you guys. Thank you for actually sticking with me on this boring stream. Oh, starfish is layered down, limb out, spread out when tired or too hot. Like the squirrel video, like squirrel or animal video where they just go like, oh, like since they die. Yeah, I'm gonna do that. I am absolutely gonna do that. So yeah, once again, to all those who have been here, thank you for watching. Make sure to like and subscribe. To like before you leave. Talk about the stream somewhat. And yeah, I'll see you on Friday.